Hi, I'm Helen Gregory, curator of McIntosh Gallery here at Western University in London, Ontario. I'd like to welcome you all to tonight's discussion in support of the exhibition Paul Walde, Glacial Resonance, which is currently on exhibit at McIntosh Gallery until March 16th, that's Saturday. This discussion is a co-presentation between McIntosh Gallery and Western University's Faculty of Arts and Humanities. So before I start tonight's event, I want to acknowledge that Western University is located on the traditional lands of the Anishinaabeg, Haudenosaunee, Lenape, and Chinongton nations on lands connected with the London Township and Sombre Treaties of 1796 and the Dish with One Spoon Covenant Wampum. With this, we respect the long-standing relationships that Indigenous nations have to this land, as they are the original caretakers. We acknowledge historical and ongoing injustices that Indigenous peoples, First Nations, Métis, and Inuit endure in Canada, and we accept responsibility as a public institution to contribute towards revealing and correcting miseducation, as well as renewing respectful relationships with Indigenous communities through our teaching, research, and community service. So I'd like to welcome everyone who has joined us tonight for what will no doubt be a fascinating conversation. We have two guest speakers, visual artist Paul Walde and professor of glacial geology, Emmanuelle Arnaud, speaking about glaciers in their art practice and scientific research, respectively. So first we'll hear from Paul and Emmanuelle individually, and then we'll open things up for more of a discussion. I know that our speakers have some questions and comments for one another, and we can also use that time to take questions from the audience. So if any attendees have questions for our speakers, please enter them in the Q&A function, and we'll get to them in the latter part of the discussion. There was already a question that came in earlier about chat, and if I'm not mistaken, we do not have chat enabled for this presentation. So I'm going to introduce our two speakers in alphabetical order, but then we're going to hear from Paul first, and then we're going to hear from Emmanuelle. So Emmanuelle Arnaud grew up in France, and she came to Canada when she was 10. In university, she was passionate about geography and history. In the end, she decided to pursue graduate studies in geography, following a summer position where she did field work throughout Southern Ontario. She completed her MSc degree with fieldwork on Vancouver Island, looking at the impact of forestry as recorded in lake sediments. After completing her master's degree, she returned to Hamilton for her PhD, where she continued to focus on the sedimentary record of environmental change, but this time focused on some very old rocks and the geological record of an ancient glaciation. She eventually became a professor and an active member of the Morwick G360 Groundwater Research Institute at the University of Guelph, where she focuses on the impact of geology on modern groundwater flow systems and their contaminants. Emmanuelle also enjoys teaching and mentoring students and is currently the Assistant Dean OAC graduate programs, where she's helping to develop new graduate training opportunities for students. And Paul Walde is an interdisciplinary artist living in Victoria, Canada, on Lekwungen territory, where he is professor of visual arts in the university or at the University of Victoria. For the past 30 years, his work has been engaged with addressing environmental issues, including exploring non-human activity and communication, global warming, deforestation, land use, endangered species, and the art world. Originally trained as a painter, Walde's music and sound compositions have become a prominent feature in his artwork for the past 20 years. He is best known for his interdisciplinary performance works staged in the natural environment, and documentation of these events is frequently used as the basis of Walde's sound and video installations, which have been the subject of exhibitions nationally and internationally. Recent exhibitions include Alaska Variations at Indexical in Santa Cruz, California, Hyper Possible, the third Coventry Biennale at the Herbert Art Gallery and Museum in Coventry, UK, Ecologies, Song for the Earth at Musée des Beaux-Arts de Montréal in Quebec, in Montreal, I guess. And Weeks Feel Like Days, Months Feel Like Years at the Anchorage Museum in Alaska. Walde holds a BFA from Western University and an MFA from New York and an MFA from New York University, and has been the recipient of numerous grants and awards. Walde is a founding member of Audio Lodge, a Canadian sound art collective, and LASAM Music's Experimental Music Unit, a Victoria-based sound and music ensemble. Since 2021, he has been a member of a Winnecola Tree of Life, an Indigenous-led research group focused on forest preservation and restoration through the confluence of Indigenous knowledge, scientific research, and the arts. And just a reminder again, so for anyone who hasn't seen Paul's show at McIntosh yet, it consists of 2 video installations, which were created 10 years apart. Requiem for a Glacier, which was completed in 2013, and Glacial, which was completed in 2023. The 2 works create a fascinating dialogue about how much or how little has changed in terms of glacial melt. And now I'm going to turn it over to Paul so he can discuss, he can talk about his work.
Wonderful. Thank you, Helen. And look forward to chatting with everyone and answering your questions. I'm going to go through, show a little bit of Requiem and for Glacier and Glacial, which are the 2 works that are on display right now, and talk a little bit about how I made them, because that's usually what people have a lot of questions about. And so hopefully, I'm going to try sharing my screen right now and hopefully bring that up. So I can pop open that window and try to do this. Share screen, share sound. Okay. Okay, hopefully everyone's seeing that. Great. So this is the Farnham Glacier, and this is where we staged Requiem for a Glacier, and in 2013. And one of the questions that people have been asking lately is why glaciers? And for me, it came out of an interest in climate change. I became interested in climate change specifically when I visited the Yukon in 2003, so 10 years before this, and saw that permafrost was melting. And I hadn't really heard a whole lot about that in the media at that time. People were talking about the greenhouse effect and things like that when I was a kid, but I hadn't seen anything firsthand. And in 2011, well, actually, I'll back up a little bit. While I was teaching at Western, I was the artist in residence at the Biotron, which is an experimental research lab for the study of climate change. And so even though I didn't do a whole lot of projects there, it was something that was pretty interesting to be around scientists that were talking about this problem. So that was something I wanted to engage more in my work. And in 2011, when I got an invite from Kira Lynch, who is the curator at the Kaslo Cultural Center, who invited me to do a project in Kaslo, she was the one that mentioned the Farnham Glacier and actually Jumbo, which is this area. I was looking at a map while I was talking to her and trying to figure out what I might do, and saw that Kokanee Glacier was nearby. And it was Kira that suggested doing something about Jumbo. And Jumbo is, at the time, was under threat from resort development. And they were going to build this massive resort community, and they wanted the taxpayers of BC to pay for it. And of course, a lot of people were opposed to it. And it also is a location of it's a sacred site for the Tanaka people. It's where the grizzly bear spirit goes to dance. So, and I knew that Kira was interested in me doing something that had to do with music and something performative. And so I came up with the idea of doing a Requiem there. And in between the point where we dreamt up this idea and where to go, the government actually approved the resort development plan. And so I ended up using the resort development plan approval from the BC government, their press release, in the libretto for the oratorio So I ended up writing a 4-movement oratorio, and that's what a bit of the score looks like. I'd never written anything for an orchestra before. I wanted to challenge myself, and it was challenging, I can tell you. So I'm going to skip forward. At some point in the planning process, I realized that Kira hadn't actually been to the glacier, and I'd never been to a glacier before, so we didn't know how difficult it would be to get into this location, and it proved to be very, very difficult. And so this is us on a site visit in 2012, which was originally the year we were going to do it, and we figured out that it was going to be too difficult to organize and get in there in 2012. And there'd been a huge mudslide blocking the roads from the east and the west Kootenays, and that's due to climate change as well. So permafrost at high elevations is melting and causing mudslides, and that's affecting the ecosystem in these places as well. This is one of the heroes in the story, Pat Morrow. Pat Morrow is the first person to climb all 7 summits of the 7 continents and the second Canadian to climb Everest. And Pat was involved with Jumbo Wild, which was and Pat's partner, Biba, was really involved, one of the founders of Jumbo Wild, which was the environmental group that was opposed the development plan. And Pat offered to take us to this location. And, here I am at the site visit. And I have to say that it was, and this photo taken by Pat, it was a magical place. When I arrived there, it was exactly how I imagined it. So for the previous 2 years almost, I'd been dreaming about it and imagining what it would be like. And it was, this location was perfect. And then in 2013, we were able to do it. So we were able to drive in to a certain point, and then people had to hike in. And so we had an orchestra and choir, so about 55 participants there, and then volunteer drivers, catering, film crew, and so almost 100 people in all involved in this. So here we are before we start. The fellow in the orange shirt is one of our safety coordinators, and he's telling people not to go out on the ice without him, because glaciers are not safe places. And the only one who actually fell through the ice was me. So, and I didn't die, so that was good. My backpack stopped me, and I kind of fell forward. But they are formidable environments, but they're also very beautiful, and there's interesting flora and fauna up there that you won't find anywhere else, really. So here's everyone hiking up to the glacier with their instruments and their equipment. And then we set up in the afternoon and performed. And the performance was about 40 minutes. And we performed for the glacier. So I think of the site-specific performance as being a separate piece from the video installation. And the video installation is based on the site-specific performance, but it's not a concert video. And if you get to go to McIntosh and see this piece, you'll see that the performance that's there is really only on screen for about 10% of the video. And the rest of the time, there's performative vignettes of some of the soloists performing, which I'll show you shortly, and video that we shot in that location of the glacier itself. So I'm going to show you a short clip. So there's a short clip from the first movement, and that's kind of summoning everybody up to the mountain. And yeah, and they performed that part below the mountain actually, and then came up for the second movement here. So this is a still from the site-specific performance. And I'm going to skip over this one just so we can talk. There's the whole crew. You might notice that some of the folks are quite young, and then there's some quite old folks there as well. The youngest person was 12, the oldest person was 84, and the entire group came together as a community event. So people from the East and the West Kootenays, environmental activists, students, people who had just wanted to go to a glacier, had never been to one. So it was all volunteers, and yeah, it was quite a remarkable undertaking that many people came together in that way. So I feel particularly grateful to this group and the way that we were able to do this together as a community. So here's one of the performative vignettes. So this is a horn player that summons everybody up the mountains. And there's another image of him. And this is the conductor. So one of the things about the development plan was that they created a mayor and council, even though nobody lived there. You know, this is a wild space. And they were an unelected mayor and council. And so I'm using the conductor as kind of a stand-in for the mayor, and he's conducting nobody because he has no citizens. And this is Veronique Hajdu, who is the soprano soloist. And there's a sequence where she's walking across the glacier. And the music that you hear in that movement is climactic readings from Environment Canada of that area. And I took the average temperatures and assigned a note to each temperature. So you can hear the notes go up and down as the temperature goes up and down, but the overall trajectory is up, and there's a certain urgency when you hear those pitches get higher over time. And that's where she's reading the BC government's press release in Latin of their timeline of consultation. So moving on to Glacial, so 10 years later, in Requiem for a Glacier, we're
Paul?
performing.
Paul?
Yeah.
Before you move on to this, can I actually get you to go back and show that other little video clip? Because you're good
Yeah, I
for
can do that.
time.
I just want to make sure we have
And
enough time.
I really like to see it, and so that other people can see it in case I didn't make it to the show.
Okay. Oop. Okay. So Glacial. So I actually had the idea for this shortly after doing Requiem, and sometimes these things take a long time to come to fruition. I think of Requiem for the Glacier. We went there and performed. Musicians performed for the glacier. And in my work, a lot of times I like to think of the counter position, like what would be the opposite? And sometimes the opposite is very related. And so I wanted to create a work where the glacier was actually performing for the audience. And so what you see in this installation view, and this is from the Kamloops Art Gallery last year, there's instruments that are mounted on the wall and some instruments that are on the floor. And field recordings of the glacier melting are fed through these instruments using speaker drivers. So the part of the speaker that is normally attached to a paper cone that allows you to hear music, these are attached directly to the back of the instrument. And so the instrument changes that sound. And so you're hearing these sounds that are rather naturalistic, and they're being fed through a cultural apparatus. And so they suddenly take on a certain cultural aspect, I think. And what I did was, I'll show you some photos. Actually, this is actually how we made the video. So the video is all made from one giant panoramic photographic still that was cobbled together in Photoshop over the course of about a year. So I went to the Coleman Glacier, which is at Mount Baker, which I can see from my house, but it's quite far, and took a series of photographs and started stitching them together. And this is kind of what it looks like stitched together. And then plotted this out in After Effects as a camera movement. So over the course of 5 hours, you go from these extreme vistas far away to right down on the ice. And so it didn't take that long to plot out the camera movement, but it took a long time to export this. And this was something I didn't anticipate. I worked at Western, and during the Christmas holidays, the computer lab was empty, and we were able to use the computer lab as a render farm. So we had 36 computers rendering this out frame by frame. So to make sure that we didn't lose any frames. So it's quite an undertaking. And the field recording. So I used this bunch of different microphones. This is a contact microphone that's attached to a spike that's embedded in the ice. Here's another one from a different angle. And some shotgun mics and Zoom recorders, and recording meltwater on the surface, in crevasses. And so these are the sounds that are fed through these musical instruments. And when they go through the musical instrument, the instrument changes the texture and the shape of the sound. And I would play the sound through the instrument, record it, and then play that recording back, and do this repeatedly. And what happens is the sound degrades and takes on the character in the instrument, and eventually lands on the resonant frequency of the instrument. So all spaces have a resonant frequency. Every room has a resonant frequency. And that's what happens here is you're ending up with these frequencies, and then I composed with those frequencies and then reassembled the naturalistic sounds. And so over the course of 5 hours, you end up moving through these sounds from the naturalistic into what I would say is more ambient, the resonant frequencies, and then back out to the more naturalistic sounds. So this is in the recording studio. Kind of hear what dripping water through a bass sounds like. And this is back in the installation again. And here you can see that there's some very close-up views of some of these rocks that are deposited on the surface of the glacier. So when they were embedded in ice, and as the ice melts, it exposes all these rocks. And Mount Baker is a stratovolcano, so there's a lot of volcanic rock on the side of the mountain. So this is, again, it's hard to show that this was all in the same image originally, but it is. So everyone keeps asking me, how did you get the camera to move so slow? And it's a still, but it's been animated. You know, the ice twinkles, wherever there's meltwater, we've composited that in. It's kind of like a collaging video together. Here's a little view. This is with my iPhone going through So when you're in the space, you can hear each instrument sounds different. But when you stand back, they kind of all blend together. So you can hear that violin sounds much higher in pitch than the cello. The cymbal has quite a different quality as well. Yeah. Oh, is that the end? Maybe that's the end. Yeah, that's the end of my slides. So I will pass over to Emmanuelle. Thank you.
Actually, Paul, can I just ask you a very quick, not so much a question, but can I get you to elaborate briefly on one point? Because
Yeah, sure.
you've done so well for time.
I try to do it, keep it on time.
You mentioned that glacial was sort of like the opposite of Requiem for a Glacier, and kind of glossed over the idea of like who was performing for whom. So can you just speak to that a little bit?
Yeah, I
different.
wanted to, just conceptually, I was thinking about it as being the opposite. I don't actually think it is the opposite in effect, but it's a starting point. And so the idea of thinking of ways for the glacier to play to people, rather than people performing to the glacier, was how I started with that piece. So.
Oh yeah, sorry, I was muted. Yeah, I said thank you. Okay, so now we really will turn it over to Emmanuelle.
Hi. Hi, everybody. Thanks for inviting me to this event. I just wanted to say that I'm speaking to you from the University of Guelph, and that the University of Guelph resides on the treaty lands and territory of the Mississaugas of the Credit. And it's recognized that the Anishinaabe and Haudenosaunee peoples have a unique, long-standing, and ongoing relationship with the land and each other, and that the Attawattaron are also part of the archaeological record of this area. And I just wanted to say, as a geologist and an immigrant to Canada, I'm incredibly grateful for the vast and beautiful spaces that are all around us. I think this is one of the things that has kind of shaped my career and who I've become. So yeah, with that land acknowledgement, I guess I will share my screen. Okay. So hopefully that looks correct. Great. Okay, so today what I'm going to talk to you a little bit about is glaciers, geology, and groundwater, and how those three things kind of come together. With the kind introduction from Helen, I am a geologist that's teaching at the School of Environmental Sciences at the University of Guelph, and I'm also a member of the Morwick G360 Groundwater Research Institute, and you'll see why the connection is there between those two. So I was really excited to be a part of this tonight, because when Helen first contacted me, I went to the website, Paul's website, and I recognized the picture of Farnham Creek right away, because I happened to have done some work in that watershed in 2005 and 2006, early on, when I first became faculty here at the University of Guelph. So I was actually looking at those rocks that you were sitting on, Paul. We were studying those rocks, which, interestingly enough, record a time in Earth history that was also previously glaciated. So there's some very interesting juxtaposition like that throughout throughout the country where you have sort of previous ancient glacial rocks with remnants of modern glaciers today. Okay, so I'm just going to talk a little bit about what glaciers leave behind. That's the part that I study, that my research is focused on. And through my work in geology, how we can read those rocks and sediments to reconstruct Earth history, and particularly in my case, interested in glacial history. And then we'll talk a little bit about groundwater and how we can use, how I use that, my understanding of glacial geology to help manage groundwater resources. This picture is taken from Alaska, just across from the Porcupine Hills. And we were just sitting there on a glacier waiting for a lift to another spot. And I remember thinking, wow, I've never spent any time on a glacier. And then I thought, it's getting pretty cold, like your feet, you know, you don't think about these things, but it gets pretty, it's cold, even if it's sunny and warm out. Okay, so just a little bit of background. So this is kind of a cartoony representation of what glaciers leave behind as they retreat from a particular area. And they tend to leave behind lots of different things. They tend to leave behind different types of materials. So things like sands and gravels, muds, and so on, as well as topographic features that you see in the landscape. So Southern Ontario has many of these features because we were glaciated not so long ago. So things like drumlins, eskers, different types of moraines, kettle lakes, these are things that you see in previously glaciated areas. So the different types of materials that are left behind is what my work focuses on. And so sometimes it's sand and gravel, sometimes it's silt and clay, and sometimes it's a mixture of all those things together. So the Dimmick Till on the picture on the right side is a picture of what we call Dimmick. Some people refer to it as till if they know for sure that a glacier has brought it to where it rests. But essentially a Dimmick is a mixture of all those things. Bit of sand, bit of gravel, bit of silt, bit of clay. And so when we're talking about glaciers, oftentimes the word Dimmick or till comes up, and it's basically the stuff that glaciers leave behind at the base of the glacier or in front of the glacier. So they're either bulldozing material in front of the glacier, or they're freezing and thawing at the base of the glacier and picking up stuff and then smearing it on the substrate as well. Just a picture like a peanut butter and just spreading peanut butter on a piece of toast. That's essentially what the glacier does. It sort of picks up things and smears it on the landscape. Sand and gravel we get because glaciers melt, as we saw in Paul's video. They tend to melt, and then you get meltwater streams. Those meltwater streams tend to become very much like braided river, like the picture here of this braided river stream in the Yukon. And they can leave behind anything from big boulders to small pebbles to all the way down to very fine sand. As generally speaking, when you're close up to the glacier, you get to see, you know, larger pieces being carried around in the meltwater. And as you move away and the energy kind of decreases, you get to see finer sands and silt in these streams. The other piece that's common in glaciers is the lakes that are associated with them. So this is the big picture on the left is a picture of the Bering Glacier in the background, which is on the southern coast of Alaska, and Vidius Lake, which is just in front of it. So basically these happen because these lakes form because there's lots of water floating around. There's often depressions in the ground from the glacier just kind of sitting on that earth and depressing it. And then as the glacier melts, the meltwater sometimes gets stuck in places because there's different outlets. They might be blocked by ice. They might just not be running the way they used to. That water can get ponded up into lakes. And so in these areas, you tend to get silt and clay. The last piece that I want to talk a little bit about is these ice marginal settings. Oops. All right. So the ice marginal setting is just when you're right close to the ice. So in these areas, you can get basically a bit of everything because you tend to have meltwater streams running around. You tend to have ponded water. So you get a little bit of sand and gravel, a little bit of silt and clay. You also get the diamict that is deposited in, like left behind by the glacier underneath the glacier and in front of the glacier, and then that stuff kind of fluffs around because it's very melty. So during the day it'll melt a bit, stuff will kind of sloth around, and you'll get debris flows down these very uneven surfaces that are melting at different rates. So this is a picture of Solheimajökull in Iceland, and it kind of shows that sort of there's lots of dynamic variety in those settings. Dynamic processes, and then a lot of variety in terms of the sediments. So I'm going to show a couple of videos now, if they work. And so this is just a video of the Solheimajökull in Iceland. And it was work done by James Balog and his team at the Extreme Ice Survey. And this brought about a movie called Chasing Ice. I don't know if any of you saw that a few years back. But essentially what he did was he was a geographer, but he also was really into photography. And so he started taking time-lapse photographies of a number of different places, icy places in particular. So Greenland, Columbia Glacier, lots of different places. So this is in Iceland. And what I want you to get out of this video, I'm going to just start playing it right now, is you're going to see basically the glacier melting over time between those two dates, which are several years apart. And what I want you to focus in on is that front bit in front of the glacier, that area that's very dynamic. You can see there's lots going on. There's melting happening. There's a meltwater stream there. Then the water gets ponded up. Then maybe the pond drains, refills. Then there's some slumping. So as you can imagine, this kind of very dynamic setting leads to a lot of different types of sediments. So if I see a ponded water, usually I can expect silt and clay. If I see meltwater stream, I can expect sand and gravel. But as you can see over time, these things shift. And so as a geologist, what you end up with, this is just going to take you back through the whole animation, just to see again how the glacier has melted and retreated over time. And what you can see also is the surface of the glacier kind of deflates because it's melting also in the thickness as well as retreating in the background. Oops. Yeah, so 2007 to 2016. Okay, so this second video is very much the same idea, except it's much more close up. And the reason why I do that is because I find that you can see different things, and we can maybe talk about that with Paul, because I think he likes scales as well. But you can see different things at different scales. So if you step back, you can kind of see the whole glacier is moving back and just kind of get that big picture view. But if you zoom in, you start to really see just how dynamic and kind of nutty and the types of materials that are being left behind. Okay, so this is about 10 years worth of pictures. So as you can see, there's lots of bobbing around. There's a lot of instability, things moving around. There's coarse gravel here in the front. There's debris covered ice that you see kind of poking out of these brown piles, these meltwater streams. These big piles of debris kind of grow and shrink depending on whether there's ice underneath them that's melting. And we have this ponded up stuff. And we almost have like a little delta accumulating here in front of us. So there's lots going on. And in the end, the geologists use this understanding of modern systems to try and figure out what happened in the past. This is where you get a bit dizzy because it goes backwards. And forwards. Okay, so at the end of the day, the ice marginal setting, the takeaway here is it's a bit of a dog's breakfast because there's a bit of everything in this. Hopefully you can see the screen right now. And this is not my dog. Somebody asked me that before. Although my dog looks a little similar, but it's not my dog having breakfast. But basically there's a bit of everything in these settings. And so they get very complicated to study, I guess, but they're also pretty exciting. Okay, so what does this have to do with my work and with the glaciers? So a central tenet in geology is the present is the key to the past. When we're looking at sedimentary geology, which is a subdiscipline, I guess you could call it, and the present is the key to the past, it means that basically we look at different environments and we try to figure out, okay, how do they work? What are the processes? What's the topography? What are the materials? And then we use that understanding. We go to a whole bunch of different places that have rivers. Let's say if we're interested in rivers, we go to a whole bunch of different rivers, and then we kind of distill sort of the common traits of a river. And then we use that understanding to then interpret past rocks that might record rivers in the past. So this is some work that I did that we, my grad student, Laura Weaver, who's now gainfully employed, she did some work on the Waterloo moraine sediments. So this is in the Waterloo region. She went into lots of different gravel pits and put together these panels recording various deformation structures that were exposed in these settings. So she was very good artistically, and so she did these incredible sketches that sort of characterized the different layers and then how they were deformed. And then we were able to reconstruct what the ice had been doing to these sediments during the past glaciation. So there's lots going on in this picture, but you can see there's, I don't know if you can see my cursor here, but you can see this is the nose of a debris flow here, this big clunk of gravel. This area seems to have like chunks of this green stuff being incorporated in the blue things. This looks like something just kind of failed, like there might have been a big ice block underneath and then everything just kind of slumped into it with all those little faults and so on. So we can look at all these kind of deformation structures and in the gravel pits, kind of locate them where they are and so on, and then put together these conceptual kind of models of that reconstruct kind of what happened with the ice. So it came, it deformed a bunch of stuff, then it left, and it left these features in the landscape as well as in the sediments. Okay, so the last piece that kind of ties it together here is the groundwater. And so I'm interested in glaciers. I was always interested in sort of reconstructing past environments. So I like that piece. My master's work was looking at lakes and reconstructing the impact of forestry then. And then when I moved through my PhD, I looked at very old rocks, glacial rocks, and tried to reconstruct the nature of this ancient glaciation. Once I started working as a professor here at the University of Guelph, I started to shift more into applied aspects and looking at how my understanding of glacial geology could help with the managing of groundwater resources. So what I've done here is I'm showing you a kind of a slice through the earth of, if we took a slice through the earth starting from London all the way to Kingston. And basically this is what you would see if you just kind of sliced it and opened it up and looked at the insides. You would see a big layer of dark gray here, which is the Precambrian bedrock, very much like what you see in the shield rocks if you head up towards Northern Ontario. Then you would see these pale blues and grays that are the Paleozoic bedrock. This is a time period, the Paleozoic, and these are typical of the rocks you see in the Niagara Escarpment. And then the top layer here is the yellow layer, is the glacial deposits that were left behind by the last glaciation. So about 20,000 years ago, we had glaciers around here that left that sort of layer at the top. So the reason this is important is because groundwater, basically, this is a picture on the upper right about the hydrological cycle. And so the water gets into the subsurface and it's stored in pores between in rocks or in fractures in bedrock, or in pores between sand and gravel. So little open spaces. There's no big lakes under here. We're just talking about water that's kind of stored in the subsurface in between these little spaces. And so as people interested in groundwater, either using it as a resource for drinking water or agriculture, industrial, all those things, you kind of want to know where the water is and what the quality of the water is. So quantity and quality. And the quality can be affected by what we're doing on top, on the surface. So contaminants can get in various ways into these, what we call aquifers. And so where I come in is I basically work with groundwater scientists to kind of inform them of what I think that subsurface might look like. So basically having an understanding, we can't just slice through the earth on a given day. So based on my understanding of glacial environments and glacial deposits, I can help people figure out, okay, well, there's probably a sand layer here and it probably goes all the way over there or not. So I can provide sort of a framework of what I think the subsurface might look like, and then they can figure out how that might impact the quality and quantity of the water. So during the last glaciation, this was about 20,000 years ago, the little cartoon on the left. The Laurentide ice sheet covered pretty much most of Canada and down into the northern United States. And around the Great Lakes area, you basically have different lobes occupying the Great Lakes basins, and just kind of coming out of the Great Lakes basins against, you know, this southwestern Ontario region. So basically these dark lines are, these dark lines are basically ridges of debris that were dumped at the margin of these ice lobes that were coming out of Lake Ontario and Lake Erie from the south, Lake Huron and Georgian Bay from the north. So basically what I do now is I spend a fair amount of time working with folks that are drillers that can recover cores from the subsurface. And students within my research group will log those cores in detail, so they'll describe them in great amounts of detail. And then we'll try to put together sort of these cross sections or these slices through the subsurface based on a number of these drill cores in an area. So this is, for example, a cross section through the Guelph area that shows you what the different materials are in the subsurface. So the purple is the bedrock, and then the orange is gravel, the green is your diamect, and the blue is your mud, your silts and clays, and the yellow is the sand. So this is just a way to visualize what we think is in the subsurface. And then we use the information that we have about glacial environments, about the glacial history of the region, to try to figure out, you know, how extensive is that sand layer? How extensive is, you know, the clay layer, and so on. One of the things we also do is we install groundwater wells. So this on the left here is the log. So it's a graphical way to represent what's underneath the surface. And this is the work of a student of mine, Anna Best. And basically the gray well that's to the right of the log is basically a graphical representation of the well. So essentially that white tube that the man's holding is the well. It's got 7 channels, so we can sample water at 7 different depths. And we install it into the hole, we put it down the hole, and then we basically, around the areas where we have ports or openings, we put sand so that water can come in. And then when we don't have holes or openings in the tube, we put those little bentonite chips, which basically hydrate and become all clay and impervious, I guess, or impermeable. So we can have sort of a sense of, we can sample water and figure out, you know, the chemistry of that water, the quality, the water quality, if there are any issues, E. coli. You can sample for lots of different things like nitrate, other chemicals like ones you don't want in your drinking water, arsenic, for example, chlorides from salt, road salts, and things like that. So basically this setup allows us to kind of think about the geology. So the framework, like you can think of it as the box that's holding all the water and what's inside that box and what are the different materials, and then how that might impact how the water is moving through, how the contaminants are moving through. And then we come up with little conceptual diagrams like this, which basically put together a picture for the person who's trying to figure this out, of what the subsurface looks like and how that's impacted what's in the subsurface in terms of the quality of the water, the age of the water, whether it's got a lot of nitrate or not, and so on. So this was a study based on non-point source pollution, so nitrates, and we were interested in basically figuring out if these 3 different sites, which had different geology, had different impacts on how nitrate was making its way through the subsurface or not. Okay, and I'll end it here with a beautiful picture from Alaska. With some acknowledgements. I just want to acknowledge all my past and present students that contribute to this kind of work, from my lab and also from G360, the Morwick Groundwater Research Institute. And then funding sources for my research come from National Geographic, MyTax, and CERC, which is the National Natural Science and Engineering Research Council, and various ministries of the Ontario government. And that's it.
Thank you, Emmanuelle. That was absolutely amazing. I was absolutely blown away by those time-lapse videos. Like, they were fascinating.
Yeah.
Oh, also, this is such a silly observation, but What the Glaciers Leave Behind is going to be an amazing title for something, right? Like, it should be a book or a movie, or
Yeah.
it's such a good title. I can't help but like think about it like metaphorically. I don't know, just it's a verb turn of phrase. So we're doing quite well for time. We only have one question that's in the Q&A, so we'll let that sit for a little while, since it's kind of a technical question for Paul. Paul, I'm going to ask you to unmute yourself so that we can be kind of conversational now at this point. So like, I've got a couple of questions that I formulated to sort of see if I could get some conversation rolling between the two of you. But before I do that, like, having sort of listened to one another, do either of you have any questions for each other, or would you prefer to sort of just dive into the questions that I put together?
Well, I would be happy for you to ask some questions first,
Me?
and then
Okay.
I'm sure that'll lead us in a direction.
Okay, I can do that. So I know that I sort of sent this one to you guys in advance. So Emmanuelle, in some of our correspondence leading up to this this conversation, you observed, oh, sorry, that's the wrong question. I'm going to go with a different question. That's my second question. Emmanuelle, in the sciences, data is a key method of quantitatively evaluating change in a way that is viewed as quantifiable and objective. In contrast, art is often described as being open to subjective interpretation. And Paul, in your recent work, you have incorporated scientific data into your musical compositions. And you have stated that you present information to the public in a non-prescriptive way so that people can form their own opinions. So I'd like to ask both of you, what value do you feel there is to presenting data using both scientific and artistic methodologies? Do you think that this creates potential for an increased dialogue or a broader understanding of environmental issues such as climate change?
Yeah, I thought that was a great question. Like, in my mind, it greatly impacts how you see the thing, because I think a lot of people, like, I walk around and I notice things because that's what I do for work, I guess, you know, like, I'll notice little rocks, and then somebody else might be more into the biology of things, and so they'll notice all the trees and the plants and things, and then you know, and then someone else might prefer just reading it through creative writing, or experiencing it through music or sound. You know, there's lots of really neat recordings, like soundscape recordings, that people can really have a much more visceral reaction to. So I feel like I think both perspectives have a lot to provide. You know, obviously the science gives you some understanding of what the processes are, but then also the arts just can reach a whole different audience, like the rest of my family, for example, who would react much more, you know, or would find more connection with the arts than they would with the science. Like, I think my mom said she read my thesis, but you know, so.
You know, I think it was interesting, like some of the images you presented, that you're sending back as reports, you know, they're drawings and diagrams that take that information and interpret it. And I think it's, you know, all data it's just data until you interpret the data, right? And so scientists are interpreting data, artists are interpreting data. Probably the main difference is that artists don't have to be right all the time, you know.
Yeah.
We can
I don't think
sometimes
scientists are right all the time either.
we can, yeah, well, they're not always right, but we don't have to be right. And so that allows us to take liberties to explain things in maybe metaphorical ways, or other ways that might not be absolutely factual, but might be more readily able to communicate in a clear way, I guess, a point of view, or yeah. So yeah, and in my work, I'm more interested in creating experiences than delivering hard messages. And I think that was, you know, if we think about Requiem as having an activist side to it, you know, the activists had been protesting against that development for 25 years, and they weren't getting any traction. They weren't able to get that message really out beyond their own locale, and definitely difficult to get it beyond the, you know, the provincial region. And so, you know, I wasn't sure I could promise that to the group, but I said, you know, I'll definitely be hitting a different audience than the one you're hitting, for the most part. And that turned out to be true. And, you know, every time that piece gets shown in different countries, people become aware of that issue. So it's interesting that in some ways art can really, you can take something very local and speak to something that's to larger audiences on a global platform. And science does that too, but it does it in a different way. And it's more likely to talk to other colleagues in the same field or adjacent fields than to talk to someone who randomly picks up a newspaper or walks into a museum. So
Even as I was sort of formulating that question, I was kind of, you know, thinking about it in advance of this. And we had a couple of graduate students from engineering who came through, and they were actually students who I had worked with. They helped to install Brandon Vickard's Alouette satellite crash in front of the gallery. But I'd invited them to come and see the show because I knew that they would enjoy the work. One of them in particular, who's doing his PhD, and it involves climate science. And you know, he responded really really strongly to Requiem. Like he was saying, like I look at climate data every day, but you know, seeing it presented in this sort of way, it makes it really kind of interesting and meaningful. And it was nice, you know, for me to see somebody from a different discipline responding so you know, so profoundly really to the work.
Well, that's great. I love that.
Yeah, me too.
And I think that, you know, everyone's going to approach the work differently. And I think that's the other part about presenting information in this way, is that it allows it to be a little more open-ended, and allows people different access points, because it's operating in a poetic realm, and you know, it's simultaneously saying a lot of different things, some of which can be somewhat contradictory, but you put together a kind of a composite message in your mind through that experience of sitting with the work.
I really like what you just said about contradictory pieces. Like, I think arts can maybe help people hold contradictory things to side by side better. Like sometimes people with science just want the black or the white. Like, do you want me to wear the mask or not? Like, and it's like, well, you know, like, you know, people had a really hard time with some of because they wanted very clear instructions, because they think science is going to be very like straight box kind of thing, and it's not. And so maybe the arts kind of help you hold those two things together, like in a more I don't know, in a way that can make it okay, I guess. Or I'm not sure what I'm trying to say, but if I'm getting this across properly. But
Yeah,
I know.
like
but
in
there's
some ways
there's
it's beautiful. The glacier melting is beautiful. It's also horrifying. It's kind of like James Baylog has the video of this massive, like probably the biggest calving event of one of the glaciers off of Greenland. So a big chunk fell off, like the size of, and then he tells you, you know, it's like 3 times New York, or anyways, it's ginormous. And you know, it's both beautiful and horrifying, because you're just like, uh-oh, like its whole thing is falling apart. Like it's so, the scale of it is just crazy.
I think that's part that's difficult to understand, is the scale of those images.
Mm-hmm.
You know, I photoshopped out the people. There were people climbing on the glacier at Coleman Glacier when we shot the panorama, and we did a giant photo mural based off just one part of it, like a little sliver in the middle at Kamloops. And that image, I think, was 20 or 30 feet high. And we left the people in on that, and people couldn't see them
Right.
because they're like ants crawling on the
Mm-hmm.
surface, like a human
Yeah.
next, you know, clinging to the side of one of those seracs is, it's like a flea, you know. It's
Right.
so small um compared to the scale of that structure. You know, they're huge. And um I was also thinking about, you know, what's at stake when these things are melting at the rate that they're melting at. You know,
Mm-hmm.
most people don't realize that almost 2 billion people rely on glacial melt for their drinking water. So that's like, you know, over 20% of the population of the world is directly dependent on that water. And it's melting and therefore drying up at an alarming
Mm-hmm.
rate. And all the ecosystems that they support as well. So it's not just people. There's a good chunk of the world's life forms that are also dependent on that water.
Mm-hmm.
And you know, there's other cycles that depend
Yeah.
on that water too. So it's not just the immediacy of using the water once, it's how it flows into all those other systems. Um, and yeah, so that's what's really alarming. And the rate of change, I think glaciers, you know, permafrost and glaciers, the Arctic, you know, that's where we're seeing rapid change.
Yeah.
I mean, it's happening everywhere, but those are the areas that we were able to see. And, you know, things that are at the top of the mountain um, are necessarily smaller than the bottom of the mountain. If you think about the shape of a mountain being pointy, you know, the upper part is smaller. And so, uh, you know, it doesn't take a lot of change to affect a whole band on a mountain. And those ecosystems, a lot of them are in those in between places, like where the ice melts and before the trees start. There's these ecosystems, and those are what are being colonized by lower altitude um, ecosystems that are able to now move up the mountain because the permafrost is melting.
Mm-hmm.
So, you know, there's a lot of ecological damage that's going on right now. And these places are so remote and difficult to get to and dangerous that people don't really get to see them or maybe understand what's at stake. So, you know, hopefully in some small way, a work like Glacial allows people to be there without having to step foot on the glacier themselves, which is, I wouldn't recommend it for most people to go step on one of these things. Unless you're
Yeah.
super curious like I am, which is kind of, you have to be a little bit crazy to do some of these things. And
Yeah, I
otherwise,
was impressed by I'm thinking that you came into Farnham from, like, if you were looking down the hill from where you were performing, you came from that side,
that's right. We came from Invermere.
Okay.
And so we used Windermere as our base camp. And some folks were in Invermere, and Invermere is where Pat Morrow and Baba Morrow are from.
Right.
But originally we wanted to go in from the other side because most of the people were from the other side, and that wasn't easy. And that year in 2012 was the year the mudslide took out Johnson's Landing, which is a little village just north of Caslow, and 4 people died in that mudslide, and the village was completely wiped out. Everything was covered in that tragedy. So that was one of the reasons we didn't want to do another reason we didn't want to do a requiem in 2012 was because Caslow, the closest community, was kind of reeling from that tragedy as well.
I'm just
A
gonna
lot happens up there in the summer when it's melting, and it can get pretty dicey on those roads.
So I'm just going to hop in here with we're getting some comments from the audience. Now, one, you've sort of addressed this a little bit earlier on this part of during your conversation, but I did want to bring it up partly because I just really like some of the turns of phrase that she's used. And these are comments from Dolores Steinman, who says, hello, Paul, obviously. So she has said, mind-blowing presentations, thank you. Could you discuss the scales, which I think you already did? And she's inspired by the word that Emmanuelle uttered. And she said, there's so many ways that my mind went on the musical scales, the scales that fell off our eyes, and the scales that Emmanuelle, I think, was referring to. And then she goes on to say, not to minimize the scale of your individual work in the grand picture of the rapid changes that we experience. But I just liked how Dolores's mind went to the various meanings of the word scale.
Yeah, I like that. That's great. And in a way, mapping climate data onto musical scales, that allows you to hear, the magnitude of change in some way. So, I think it's definitely appropriate.
I have another one from an anonymous attendee. We've got sort of 2 questions here, and then I've got mine, and it's 8:15, so we're actually like motoring right along here. So this first question is the chance to see, or sort of a question/comment, the chance to see a glacier collapse. And how can we come to terms with the inescapable situation? Also, what were the PCBs and dioxins in the cores mentioned by Emmanuelle and the other persistent organic pollutants that persist for longer periods? As art, it reminds us, or it reminds of the 1979 movie The Stalker, where the setting is a dystopian near future where the stalker guides 2 strangers into a carefully guarded exclusion zone to wade through rivers and outflows. As he does, he constantly tests the ground or landscapes in front of him as he searches for the invisible, unknowable dangers. Or does Tarkovsky's work become real in the recreation of the glaciers disappearing and filming this as a comparison? Now, I haven't seen The Stalker. Have either of you?
I have, and Tarkovsky actually died after doing that, filming that. So he got very sick from being in those environments, kind of industrial, kind of supposed to be in the future, but it's definitely, it affected Tarkovsky in the present. And yeah, so some people think that Stalker was actually filming Stalker. It was what actually killed him. Yeah, I can't remember the rest of that question. That was a long question.
Oh, and, it's a long question. And actually, the second question is not a second question. It's just
But
it's more discussion of
the person was asking about
the
PCBs.
dioxins and the PCBs that
Yeah, so
you're referring to. So yeah.
Yeah, I guess when you're drilling core, the people drilling are trained so that if they encounter any free phase liquids that are not supposed to be there, as in like oils, or sometimes if you're expecting certain types of toxins, you wear certain types of detectors to let you know. And then you're also wearing a lot of safety gear. But generally speaking, I don't I have worked on sites with chlorinated solvents. So these are things that are used in like cleaners, degreasers in an industrial context and things like that. So there might be those types of things can get into the water. Basically, like I think if we live in a populated area, you kind of have to assume that your water is not pristine. It's being treated. You know, your municipality or whatnot. I mean, obviously, we're trying not to avoid putting contaminants in the ground. And we also have ways to kind of try to figure out, you know, how deep should we go in order to have a protective layer between us and the aquifer where the water is and things like that. So, yeah, so it depends, but you can, and then you can run analyses after the fact to try and figure out what is in there and what are some of the health concerns and things like that. And then there's also toxicology is a whole discipline, and there's all kinds of government regulations that tell you, you know, so this is the maximum amount allowable concentration that you can have in your water before it gets too much and completely unhealthy. So municipalities have to, you know, watch those, obviously, and they would stop using the wells if they get contaminated past those levels.
Okay, so we've got about 15 minutes left, and I have one more kind of broad-reaching question that I will pose to the two of you. Emmanuelle, in some of our correspondence leading up to this conversation, you observed in response to Paul's work, Requiem for a Glacier, that the presence of the orchestra and choral ensemble performing on the glacier really made you think about Indigenous ways of knowing and about the importance of their relationship to the land. I've done a little reading recently on the increasing recognition of traditional ecological knowledge or Indigenous local knowledge as an important source of lived, embodied, durational knowledge about the environment and its value to scientific research. So I'm wondering if you have had any opportunity to incorporate that into your own research. And also to Paul, I'd invite you to respond to this in terms of your experience working with a Winnecola Tree of Life.
Yeah, so I guess the way I was thinking about that when I said that was just in my mind, like it just felt like I was really struck by the sort of performance for the glacier. Like a requiem, to me, like a requiem mass is for someone who's died. And so I just thought it just brought, I guess I'm taking the course Indigenous Canada right now, and it was just funny because that week I was reading it was a module about the land and the meaning of the land and how the land is a sentient being, like they view the land as a sentient being and so on. And so it just, to me, it was quite profound how it was a performance for the land. Like I just thought that was mind-blowing. So yeah, in terms of my own research so far, it's more like in my mind, so far it's been mostly about just being aware of whose land you're on and being very respectful of that fact and acknowledging it. But I haven't managed to weave Indigenous ways of knowing in my projects. But I guess it's not too late to do that. It just, you know, it takes time. You want to, not that I don't want to take the time, but I think I'm building up sort of relationships that might bear fruit in the future if they're interested in some of the work that I'm doing. I'd be very much willing to collaborate, but so far I have not been able to do that. I did have a student a long time ago who was actually my field assistant when we were up Jumbo Creek, and he had spent some time in the Yukon on a trap line, And he was saying how he took my glacial geology course, and he was saying how in the indigenous stories from the area that he was in were basically telling the glacial history of that area, that there was these stories that had been passed down that were very much consistent with what we were talking about in class from based on scientific studies that have been done in the region. So that was, I thought, really interesting.
Mhm.
Yeah.
Paul?
Yeah, I can speak to that in a couple ways. I think maybe going back to Requiem first, and that site being a sacred site for the Tanaka people, where the grizzly bear spirit goes to dance. And the scientists were corroborating that, saying, this is kind of a keystone environment. Like if you took it out, it would separate different not quite species, but different communities of grizzly bears. So it's kind of like a meeting place where they would move from one side to another. And so it's really important corridor for that species. And in all the non-Indigenous talk about that space, no one was talking about it as a sacred site. So bringing a sacred text and kind of a religious, more of a vibe through the music, was a way to bring it into that realm for non-Indigenous people. And yeah, it's in Latin, so it's got overtones of liturgy, but it's also the language of the law, and it's the language of science. So so I was thinking about all those things in making that work go in that direction. And my current work is far more directly engaged with Indigenous communities. So I'm part of a group called the Winikiola Tree of Life that was founded by Randy Cook, who's a hereditary chief of Montegila people, which is a Kwakwa nation from northern Vancouver Island. And we've been spending time on the land looking at primary forests and clear cuts, and working with scientists as well. So people who are involved in forest ecology, like Suzanne Simard and Rachel Holt and Teresa Ryan, and Indigenous knowledge keepers like Randy, bringing some of the elders from his community out onto the land. And then there's myself and Kelly Richardson and Lindsay Delrond, as well as Randy, who's also an artist, who are part of the art team, and curator Stephanie Smith. So it's quite an amazing collaboration in that way. And so the project I'm working on right now is an opera for the old growth, dealing with the human side of that, including some Indigenous perspectives, as well as scientific ideas about what a forest is, and then trying to communicate with the forest as well. And so, and in a way that kind of goes with the direction in which I'm thinking about my work. I think Requiem was kind of maybe more of a warning, like, hey, if everybody knows that the world's warming up and glaciers are melting, maybe people will do something about it. And I think, this over 10 years later, I'm more interested in trying to imagine what a culture looks like that's more aligned with the environment and aligned with that science, and then aligned with Indigenous values. Because Indigenous values, they're Indigenous because people were able to live on the land in a sustainable way, or a regenerative way, even better than sustainable, and influence the environment in positive feedback ways. So I think those are hopeful things to look at when you're facing crises, because there's solutions, there's human knowledge and human ways of being that can help us. And these environments can help us, forests can help us, glaciers can help us, but we have to find a way to not destroy them. And so, that's the work, is trying to restore that balance and imagining a culture that can do that.
Thanks, Paul. And I just wanted to, so I'm not going to ask any additional questions because we're kind of almost to time, but I did want to just mention that, we actually had somebody who was tuning in from Seoul, Korea, who was asking questions, but she's also just said that you answered them. So that was really good. Yeah, we just a few sort of final comments from people in the Q&A, basically just thanking you for an excellent discussion, which I would have to concur with. That was really great. Yes, I just want to thank you both for doing this. I mean, it's always a little bit of a risk to take sort of two people who don't know each other, but and who come from different disciplines, but who have something in common, and you hope for the best, and you hope that a generative conversation comes out of it. But I thought this was really great. So thank you both so much for doing this, and thank you to everybody who tuned in. And again, just to remind everybody that Paul's show ends on March 16th. That's this Saturday. So if you're in the vicinity and you can get here to see the show, then you should definitely make the journey, because it's totally worth it.